Okay, so before we start, a couple notes on the test. Here's the location. It's going to be Sanford Fleming Building, room 2202. I don't think I've ever been there, but from the pictures online, it looks nice. Individual desks, good lighting, all that kind of thing. We'll start at 1:10 exactly, so it'd be a good idea to show up at 1, sort of get settled in. And the test is going to be 2 hours, so it'll go until 3:10. So 2 full hours. Bring a pencil, pen or pencil, doesn't matter which, and your student card if you will. And no aids or no notes are going to be allowed. Also, by popular request, I've put up a sample question on Quarkus. So you scroll right down to the bottom of the Quarkus page. I've given you the exact, so there's a document file with the exact prompt that you're going to be given on the test, and then one question. I did the micro theory of concepts. And there's 3 different answers with 3 different marks on them, and comments all down the side about bits that I thought were good in the answers and bits that I thought were lacking in the answers. Full disclosure, 2 of them are modified versions of actual student answers from last year's tests, and one of them I wrote. I gave myself generously the highest mark. So I thought I did very well. It was a low pressure situation. Anyway, so quick questions about the test before we dive in. Yeah?
Will writing your name on our test increase our mark?
Not at all. In fact, I'll get all the marks from you. So that would be, I think I can still bump up my mark from this class when I took it in 2001. So feel free to do that, but I will accrue all the credit. Anybody else? We're all clear on the structure of the test. What's gonna happen? You're gonna have a list of 10 terms. You're gonna pick 6 of them. You're gonna write fairly detailed answers about all of them. I think in the sample answer that I wrote, I didn't do any kind of insightful novel connections. I just did connections that I'd already made in class. That's okay. If you do enough of that, if you do enough sort of integrative work for material we talked about in class, that's enough to get you full marks. But doing a novel connection, generating a novel critique or a novel argument for the position, all of that are just ways of demonstrating that you really understand what you're talking about. So those are all good things to do as well that probably aren't reflected in the answer that I wrote. Yeah? Okay, so it's not Tuesday, Thursday next week, right? July or June 6th. Yeah? Yeah.
You're not going to drill us with like specific names of like who came up with the theory or anything like that.
Good question. No, I will not. No, I will not. So it's a good thing to include in your answers. It's a good thing to include names or the kind of studies that people wrote. Those are ways of showing me that you've been listening, that you understand. But that's not required. And none of the questions are going to be like, what did, Holyoake say? That's not the way that I'm going to ask you. So I'm assuming that you've got these indexed by the name of the idea. And I've been trying to present it in terms of, here's the name of the idea, and then I associate a few names with it. So I'll be testing you in the same way that I've been presenting it, the names of the ideas, like micro theory of concepts, right? That's the name of the idea. If you remember who wrote it, that's great. If you remember the names of the people, years of the things, I'm always impressed by that because I'm really, really bad at recalling that stuff off the top of my head. But that's not really what I'm looking for. Those are good data points. It's all worth marks. But like what I'm really looking for is whether you understand the material. Yeah? You understand the ideas. And they're going to be the big ideas from the course. Okay? If there's nothing else, then we'll jump into new stuff. Right. So quick review. Okay, so we've been talking about insight problem solving. We've been talking about insight because we found with Newell and Simon's really intuitive and sort of appealing search space model of problem solving, there was a big problem, and that was the problem of avoiding combinatorial explosion. Just searching through the space puts you in a position where you have to do as many computations as there are fundamental particles in the universe times nanoseconds since the Big Bang, and that's just not the kind of day you want to have. So what we found was that problem solving, the heart of human level problem solving, the kind of problem solving that we do when we're facing unclear problems, is insight, the ability to not just frame a problem, but reframe it as necessary. Insight is switching problem formulations. You've got one formulation that's not working for you, and you insightfully reformulate the problem. We looked at last time we looked at just the debate between two broad schools of thought on how insight problem solving works. The search inference framework, which is essentially an expansion and extension of the search space model of Newell and Simon. So these are just people who recognize that insight is a thing that they need to deal with somehow, and their claim is basically that you can just expand Newell and Simon's search space model using heuristics to move through a search space to insight problems as well. So their view is that insight is like any other kind of problem solving. It's a search through a space, a somewhat expanded, to be fair, search through a space, and that it's a kind of cognitive inferential activity. You're doing inferences in just the same way that you do for any well-defined problem, any non-insight problem. Basically, you're just doing this search for the proper rules to solve your problem. And we compared that to the Gestalt tradition, which involves perceptual restructuring. That is, they argue that it's not just inferential, it's not just applying rules to symbols. It's about a kind of perceptual restructuring. I think last time I overemphasized I think I used the word literally and shouldn't have when I said it was literally a perceptual restructuring, because some of the problems that people deal with are just linguistic. Like you can have an insight problem, and we'll see a bunch of examples today, where the problem is just a set of sentences. So it's funny to say that it's literally perceptual restructuring. What it literally is a kind of attentional restructuring, a kind of reshaping the way that your attention and your frame for the problem sort of help you grasp it. So in this sense, it's still, even though not always literally perception, it's more like perception than doing inferences, like more like perceiving the world than doing 5 times 20 kind of thing. Okay, so those are the two quite broad schools of thought. We saw the kind of proposal this was from the search inference framework, where they thought, okay, we're very aware, we in the search inference framework are very aware of this problem of combinatorial explosion. It came up from Newell and Simon, so it's been struggling with this has been part of the research program from the beginning. So they gave us this picture of searching through memory boxes. So you don't search your entire memory for a solution. What you do is search through the problem formulation that you're in, and then once you're exhausted that box that you're in, you switch to a new box, and you just move boxes until you find one that contains a similar problem to the one that you're facing now, and then you just transfer that solution that you remember to the problem that you're facing. We talked about a bunch of problems with this. I won't go into great detail because we did it last time. And we also talked about the Gestalt Psychology picture, which was focused on perceptual holes and perceptual restructuring, just like you're able to perceptually restructure this Necker cube into having 2 different parts of it being the front, right? And we talked a little bit about how they weren't in the early days of Gestalt psychology, these people were not awesome experimentalists or theorists, but that people in their tradition later in the 20th century came up with some experiments that we looked at last time, which suggested basically that their thesis was right, that insight problem solving has a lot more to do with perceptual restructuring or perceptual-like restructuring than it does with simply cranking through a bunch of inferences. And in support of that, I basically spent the whole time last time making the case for the Gestalt view. In support of that, we talked about the individual difference methodologies studies that we talked about, this stuff about how if you're good at doing stuff like cognitive leaping, if you're good at doing things like identifying what a blurry image is, then you're more likely to be good at solving insight problems. And that suggested that there's basically 2 different cognitive skills that you're drawing on when you're solving an insight problem versus when you're solving a non-insight problem. So if that's right, then that suggests that it's not just, so the search inference framework says, it's just an extension of your regular problem solving skills. When you do an insight problem, you're just doing the same thing but more. And the individual differences methodologies results that we found, that we talked about last time, kind of put a damper on that notion. That is, if you're using basically different cognitive faculties to deal with insight problems, and that's what these experiments was suggesting, it's really hard to make the argument that you're just doing more of the same thing. It seems like you're doing something different, right? We need a different type of explanation for understanding how we do insight than how we do non-insight problems. Okay, and that's where we got to, I believe. How are we feeling about that? Reasonably okay? Okay. So, let's do some more stuff about insight. So, last time we saw that Weisberg and Alba arguing that insight problems are just like non-insight problems. By the 1990s, based on the kind of evidence that we've been talking about, it was pretty clear that insight is a real phenomena, that it's a distinct phenomena than other types of problem solving. So they kind of accepted that there was at least something to explain here. There's at least a distinct phenomena calling for a distinct sort of explanation. But they were persistent in the sense that they wanted to continue to develop their search inference framework. So this is a genuine development of the search inference framework, where they're now suggesting that it's not just one search through memory, but two different types of search through memory. So there's, instead of just searching your memory, you do a kind of, first you do a sort of within problem formulation search, looking through the search space, and then when you get frustrated enough that you're willing to step back from the problem, try to do problem solving on problem solving, what you do is switch to a meta-level search. That is to say, you shift your search from within a problem space to a search between problem spaces. You're no longer just digging through your memories. What you're doing is searching through the space of possible ways of formulating the problem. And we'll see today, I'll make the case for you today, there's probably something to this. That is, it's not just wrong that you're doing something. I mean, at least we've got the idea that you're doing something different in insight problem solving. So that seems like progress at least. The question is whether this meta-level search is going to be sufficient to understand insight problem solving. So the danger here, of course, is that all the same problems from the search inference framework, or sort of a search through a space model, are going to reappear at the meta level. So we've got, of course, the problem of combinatorial explosion at the meta level as well. They haven't forgotten this. They didn't just sort of forget that this was an issue. So what's their solution going to be? What are they going to say is the right way of navigating the meta level search? Well, it's the same solution as before, but applied to the meta level. They're going to suggest that we need heuristics. So heuristics are, of course, the way within a problem space that we dealt with combinatorial explosion. They think that we're going to, they hope that you can understand the meta level search through a heuristic as well. So Kaplan and Simon, this is the same Simon as from before, from Newell and Simon. They say the following, and notice the title of this paper, In Search of Insight. So they're definitely trying to kind of preserve by extending the search space model of problem solving. They say the following. They say, we show that the same processes that are ordinarily used to search within a problem space can be used to search for a problem space. That is, a problem representation. So they're really just sort of taking a step up in the kind of meta-level search space stuff. Okay, so what's their heuristic? And they present a heuristic. They think that they have a proposal, at least, for how to think about this meta-level search, to figure out a way of constraining that meta-level search so that you don't get overwhelmed. And it's the following. They have a meta-level heuristic called the notice invariance heuristic. And it goes like this. They say, pay attention to those features of failed problem formulations that stay the same. So you've tried a few different problem formulations, and you ask yourself, what's the same? And you fail. So you try one and you fail, you try another and you fail, you try a third and you fail. They recommend that what you should do is ask yourself, what's the same between these different problem formulations? Just as an example, recall our struggles to figure out categorization. We made this move in categorization. We said, Here's a couple of different, so we got the similarity model, we got the classical model, we got the prototype model, and I suggested to you that what we should do is take a step back from these failures and ask ourselves, what's common amongst all of these failed attempts? And what we extracted from these was the idea that concepts are feature lists. Remember that? So all three of these represented the structure of concepts as lists of features, unstructured lists of features. And when we moved from these to the microtheory, I presented to you as at least a kind of progress that we were no longer just assuming unstructured feature lists. So that's what we did. We noticed an invariance amongst all of our failed attempts and tried to use that to move beyond our failure, try to move towards something that would be more successful for us. So that's what they're suggesting that you do when you do a meta-level search in any kind of problem solving. You try a thing and it doesn't work, you try another thing, it doesn't work, try a third thing, it doesn't work, and then you use, by looking at your failures, you try to figure out what's similar amongst all of them. And, you know, that's not bad. That seems like it works okay. We did it, right? Okay. Let's some problems. Okay, so the most important, for my money, the most important problem with this is a kind of dialectical problem. So their attempt is to rehabilitate and extend the search inference framework to deal with insight problems. But notice the language that they use. The notice invariance problem, or heuristic. You notice the invariance. And does that sound like an inferential process or a perceptual one to you? Noticing is something that you do with your attention, right? So, sorry? Yeah, it's perception. It at least sounds like a perceptual process, right? Now, you could make it an inferential process if you provided a formalization of how you do this and how that you leverage it into a kind of problem solution, right? You could cache this out, so they're using perceptual language. Potentially, you could cache that out in non-perceptual language. You could formalize it such that a computer, which doesn't really have attention in the way we have, could do it. But there's some problems there as well. So recall Nelson Goodman's problem of similarity, where any two things have an infinite number of features in common. So I've got three different attempts to understand categorization. Well, I'm going to notice some invariance amongst those. I used language for them all. All of them were generated by humans. None of them were generated in space. Maybe those are the problems. Yeah?
Doesn't this also kind of get back to the categorization issue of if I'm noticing these things, which ones do I care about?
Exactly.
What sticks and what doesn't when I'm throwing stuff at the wall?
Exactly. So Goodman's problem tumbles into the next problem, which is, of course, you don't just notice all of the invariants because there's an infinite number. You need to narrow in on just the relevant invariants, the ones that matter, the ones that make a difference. And that's not easy. It's not a thing that we know how to formalize right now. So noticing invariance is a heuristic. It's a heuristic that we can use. It's a good heuristic. If you're failing a lot, a really smart thing to do is to ask yourself, well, what's similar between all of these failures? It's if you have relationship troubles, chronic relationship troubles, and all of your relationships are failing in similar ways, go to a therapist and they can help you extract the invariance from those processes. That's part of what you should be doing, right? So it's not that it's a bad heuristic, it's a good heuristic, but it's a heuristic that you employ by being smart. So it's not going to be a heuristic that we can formalize easily, right? So we'll see shortly that actually paying attention to your failures is a really good way of getting better at things. So good heuristic, but it hasn't been formalized. That's what I would propose. So this extension to the search inference framework where you have a failure to find a solution in one problem representation. They call it problem representation. We could call it a frame or a problem space, kind of equivalent terms. you step back and you try another one, and then you fail in that one, you fail in another, you fail in another, and then you just try to notice what's similar between all of them. That might even be right? That might even be a reasonable description of how we do insight problem solving. It's just that it hasn't provided us. Again, we're putting the bar really high in this class. The really high bar is it needs to be formalized right to the ground so that we can mechanize it. That's not typically a constraint. Like throughout the history of psychology, that's not a constraint that people have felt themselves necessarily need to be held up to. It's really only when we introduce the artificial intelligence project as a shared project between psychology, philosophy, linguistics, AI. Once we put these all together, then we need to really raise our game and produce theories that are not just descriptively adequate, but actually formalizable and mechanizable. So this is this is good science. It's not that it's bad science. It's a good hypothesis about how we do it, but it doesn't, as of this stage, rise to the level of satisfying the naturalistic imperative. Okay. So, questions about that before we move on? Yeah?
How do we know that we succeeded or that we failed? I guess that's the other issue. Not just what's important, but how do I know that I'm doing it right or that I've done it right?
So Newland-Simon's original formulation of this is that there's an initial state and a goal state, and once you've transformed the initial state into the goal state, you win. That's it. You've succeeded. So unless you have some representation of what you're trying to do, I don't know if you can even begin the problem-solving process. So we need some sense. Before you can start problem solving, you need to know what you're trying to solve. Yeah? Yeah. Okay. So that's their answer. And you can legitimately ask, okay, so where does the goal state come from? And that's a big, difficult question, which they really don't tell us anything about. So remember, we talked about how in the search space model of problem solving, they just assume that it's given that you've got a representation of the initial state and the goal state and the operators. So that's a big question to which they don't really hold themselves to need to provide an answer.
Do the heuristics themselves and in which we apply them have a goal state? Because we're trying to solve a problem with that, but if we use a combination of heuristics, we might not, okay, this one solves 50% of the problem, this one solves 30% of the problem. We don't know that, right?
So when you're applying a heuristic as a problem-solving method, it assumes that you've got a goal state. It assumes that you've got a representation of the goal state. Without that, you couldn't even apply the heuristic. So.
The heuristic, does this model factor in that we have partial goal states, or that the goal state can be partially solved? Like our heuristic gets 50% of the way, or 30% of the way. If I'm searching through my space problems or trying to come up with a strategy, how am I gaining which one is better than the other one? Sure, it gets me closer to my goal state, but how am I coming up with how I measure that?
So we talked last time about Simon introducing this notion of satisficing, where where you get it close enough to your goal state. Presumably, if you formalized how you represent goal states, you could formalize partial satisfaction of those goal states. They don't really get into it precisely because of the kinds of machines that they're building. So this research program is not just in psychology. They're actually building machines that try to use these methods to solve things. But the kind of problems that they've built these machines to solve are problems like deriving a theorem in logic or winning at chess. Chess was one of their big ones. So in chess, there's no partial victory. There's checkmate or a draw. I guess draw is partial victory. But the goal is very clearly defined. You don't need to do any kind of fancy statistics to say how close you were to checkmate. You just say, did you get there or did you not? So I don't think that they worried too much about it. And that might have been, there's all kinds of problems in the background here, which I think it's very reasonable for a researcher to say, that's for down the road. Let's just get the basics worked out, and then we'll worry about partial satisfaction of goals and all of these big prior problems, contextual problems later on. It's already hard enough to do this, so. Okay. So let's talk a little bit about transfer in problem solving. So we talked about this the very first class about how you want we talked about metaphors for a little bit. We talked about this in the context of scientific theories, how you want your theories to apply widely. And we talked about it in memory, how it looks very much like what your memory is set up to do is help you transfer prior experiences into future problems that you need to solve, right? That seems to be what we're mostly set up for. On average, the neurotypical person doesn't remember exactly what happens. They remember the important bits of it to them, the relevant bits that they can use to deal with their problems in the future. So maybe the same idea can help in problem solving. So this is at least part of the search inference framework of how do you search through your memory for things that would be helpful? Like nobody solves a problem. We don't typically solve problems just in a vacuum, right? You use your prior experiences, things you've learned, skills you've built, and you try to bring them to bear on the problem that you're dealing with in the present, right? So let's try to think a little bit about transfer and problem solving, which is particularly difficult in insight problem solving because it's not clear what you're trying to transfer. We talked about this a little when we were critiquing the searching through memory boxes view of problem solving. So maybe the same basic thing can help. I mean, this seems like common sense, right? So I'm trying to solve a problem. So what I do is find an analogous problem in memory and I transfer the solution that I had there to the problem that I'm working on. And maybe that's what insight problem solving is, just grabbing a solution from a distantly related domain and bringing it over to the problem you're dealing with now.
It's like out of the partial solution. It is like you come up with one solution, it's not a one-fit-all kind of thing. My solution to one problem may solve only 80% of my other problem. Like there has to be, like your heuristics have to be partial or we have to have some weighting there.
Well, we'll see some examples where, very shortly, where there's a complete solution that you could transfer. So all of that, we'll do a bunch of new insight problems today where there's just like they give people a problem that they could completely clean out the problem, solve it utterly if they just made the appropriate transfers. So it is still a question, but sometimes there really is a solution to your problems, I promise you. Sometimes you could actually solve your problems. Not often, but savor it when it happens. Okay, so here's a new insight problem, one I haven't showed you before. If you've seen this before, shush, shush, shush. So telling us the answer when you've seen it before just shows that you're good at remembering things. So this is the Dunker radiation problem. So the Dunker radiation problem was presented first in like 1945 in a paper on problem solving. I'll describe for you right now an experiment from the 80s from Gick and Holyoake on analogical problem solving. So here's the problem. Somebody's got a tumor in the middle of their brain, right in the middle, right in the center. And in 1945, when X-rays were magic, they're like, we need to find, you want to use X-rays to destroy the tumor. However, an X-ray strong enough to destroy the tumor will also destroy all the healthy tissue around the brain. So, how do you destroy the tumor using the X-rays without destroying the healthy tissue? Yeah.
And imagine you have to localize the X-ray so the radiation concentrates for
That's part of the solution. Yeah. Yeah. You got to localize it somehow. Okay. Tell me when you're sick of this one. Yeah. Yeah.
I would say, I guess the idea is to not affect the healthy tissue.
As little as possible.
So why not just make a direct path to the tumor and then cut your losses with the healthy tissue that's
Oof. Oof. That's very direct. That's very direct problem solving. Yeah. Yeah. But part of the stipulation was we're trying to avoid destroying the healthy tissue around the brain. Yeah.
Use two low-powered beams that then collide at the tumor point and then become a strong kind of point power.
That's it. That's it. So the solution that they think is there's multiple solutions, but the solution that they were kind of fishing for was, they said 3. So you get 3 beams all coming from different directions converging on the tumor so you could use beams that are 1/3 as powerful, sparing the healthy tissue, they all come together in the middle where the tumor is, destroying it. Okay. And by the way, this was proposed in the 40s when this was like a sci-fi scenario because X-rays were still magic. But this is actually how they treat some brain tumors with radiation now. They call it a gamma knife. That's the most sci-fi thing I have ever heard. Okay, so this is the actual method of dealing with these things is doing this thing where you have the X-rays converge. Okay, so that wasn't the experiment though. That's just the insight problem. So here's the experiment. They were trying to study people's ability to transfer solutions from similar problems to this problem, to the Dunker radiation problem. So what they did was they gave them a little story that they thought was analogous to the Dunker radiation problem. Let me read it to you. Here we go. So shortly before giving them the Dunker radiation problem, so they sit them down, they tell them they're going to have them read a little story, and they told them it's a reading comprehension test. And everybody's, of course, feeling very good about themselves because they're reading this really well. So the story is, a general wishes to capture a fortress located in the center of a country. There are many roads radiating outward from the fortress. All have been mined, in the sense of there are mines under them, like explosives under them, so that while small groups of men can pass over the road safely, any large force will detonate the mines. A full-scale direct attack is therefore impossible. The general's solution is to divide his army into small groups, send each group to the head of a different road, and have the groups converge simultaneously on the fortress. Okay, so they sit them down, they give them this little story, tell them it's a reading comprehension test because psychologists are always trying to trick you. And then they give them a couple of distractor tasks, just do some multiplication or something like that, something to get their mind off it. And then shortly after, they give them the Dunker radiation problem to see if people are able to transfer. Is it clear how that story is analogous to the Dunker radiation problem? Like, the solution to the Dunker radiation problem is contained in that story. You can't send your entire force along one path. The solution is therefore to split up your force and have it converge in the middle, right? Analogous solution. And they tested to see if that helped people solve the Dunker radiation problem. And it didn't. It didn't. And probably you kind of don't believe me, or you don't believe that if it was you sitting in that room, you would have failed to make the connection. Because we all want to believe that we are magic. But people just did not make the connection between these two things. They were unable to transfer from one to the other. Which is weird and kind of disturbing, right? You want to think better of I want to think better of myself than that. That if I was given a problem to which there's an analogous solution, and I got the next problem like minutes later, that I'd be able to do the transfer. Based on this and a whole bunch of other research that was going on at the time, about like cognitive biases and stuff, people started to wonder if we were smart enough for democracy. Some head shakes. I mean, people assumed that we were much more rational than we thought. Like, we were much more rational than we turn out to be. We turn out to be like the best reasoners on the planet, but the bar is apparently very low. Like, we're so far from ideal rationality, the kind of ideal rationality that you might think, that people started to seriously worry about democracy. My favorite quote on democracy is from the war criminal Winston Churchill, who said, democracy is the worst form of government except for all of the others that we've tried. So we're probably stuck with it for now. Another conclusion that you could take from this research is that we just don't understand insight problem solving yet. So notice in the debate that we've been going on about this, the two visions of insight problem solving we've been thinking about, one in which it's inferential, that the problem is that you don't have the right propositions in your head, right? That's the search inference framework, that it's really a matter of having the correct propositions, the correct sentences in your head. The Gestalt people said it's about perceptual restructuring. And this story that I gave you is, of course, a series of propositions. So one possible conclusion that you might come to here is that the cue was of the wrong form. You gave somebody a propositional hint, and what they needed was some kind of procedural hint. They needed a different type of help because insight problem solving is a different type of problem. Yeah? So we'll look at a bunch of experiments that test that possibility. And yeah. Okay. So Lockhart, Lamon, and Gick, 1988, did this study. They tried to tease apart propositional cues from procedural cues. So maybe you can help people solve insight problems just by giving them a different sort of help. Okay. These are not deeply difficult insight problems. They actually read like really like dad jokes, but so here's one. So they gave people the following. Here's one of their insight problems. A man who lived in a small town married 20 different women of the same town. All are still living, and he never divorced a single one of them. Yet he broke no law. Can you explain?
Did they marry each other?
No. This is the 80s, so gay marriage is illegal and polygamy is illegal. Yeah.
He was literally marrying them.
He's the preacher. He's the clergyman. Bah, bah, bah. That's the funniest one. The rest are even worse. Okay. Sorry, I just read this out. Okay, so they wanted to see what kind of cues would help people solve this insight problem. They gave them two different types of help and tried to see which one improved people's performance. So they did a bunch of these. This is just one example, but so they gave people a declarative version where they just give them the information, and a puzzle version, which was supposed to be a more procedural cue. So before they gave them the insight problem, the deep philosophical problem of the clergyman marrying people, they had them do a bunch of reading. Again, they tell them that they're doing a reading comprehension task, and people are like, yeah, I'm reading the heck out of these. Okay, and in amongst the sentences they were asked to read, there's a whole bunch of sentences, some of which were cues for the insight problems and some of which weren't. They either put one or the other of these in there. So either the declarative version says, it made the clergyman happy to marry several women each week. There's nothing, so the word clergyman is right up front there. So it's just the difference in the structure of the sentence, right? So the word clergyman is right up front. You're never confused about, so there's two meanings of the word married here, right? Just to squeeze the last bits of joy out of this. There's two meanings of the word married, right? Either you become married or you enact a marriage. And the assumption is, the people's default tends to be, and this is why we all took a minute to sort that out, is that when you say you were married, you assume that you're the one becoming married. So there's a dominant and a subdominant meaning. This declarative version cues you into the dominant meaning right away, right? There's no confusion, you're at no point puzzled. Then the puzzle version was, the man married several women each week because it made him happy, pause, and then clergyman, right? So when you read the first one, you are at no point confused about what the sentence is saying. You're not like, what? But when you read the second one, it'll take you, on average, it'll take you a second to be like, what are you? No. Oh, okay. So what they're really doing is just inducing a moment of confusion, a moment of what? And causing people to try to engage in this problem-solving behavior. Because they presented you, the puzzle version presents you a mild puzzle, right? It's a sentence that doesn't make any sense until you hear the word clergyman. Okay. And guess which one of these facilitated insight problem solving? Yeah. The puzzle version. The puzzle version. Yeah. And why did I ask you to guess that?
It's computationally expensive for you to
So that's, I mean, that's, yeah, so that's the idea of why, so why is it that the puzzle version facilitates the insight more than the declarative version? Because when you read the declarative version, you're not processing it as a puzzle. Remember that stuff from memory where we talked about transfer appropriate processing? The way in which you take in information tends to be the way in which you'll be able to reproduce it later, right? So if you read this cue as a puzzle, when you're presented it again as a puzzle, you're more likely to be able to make the transfer from the stuff in your memory to the problem that you're facing in the present. Yeah?
Wait, is the clergyman just by itself?
Yeah.
So wouldn't that kind of just be like, this is important?
Yes.
Or is it weird?
Yes. We'll see. That is an issue. So you might legitimately worry about the fact that these are two different cues, right? So the ideas are all the same, but it is a little odd that you got this clergyman thing here. We'll see in a second a study where they control for that. So that's a good worry, and they took it seriously enough that they thought it was worth doing more experiments to kind of tease it out. Yeah. So. Yeah.
Is this not by extension though like a bit of a context problem? Like,
What do you mean context problem?
I have more information just from the start. So you're telling me that the man in question is a clergyman in the first statement.
Yeah.
So I'm perceptually seeing this as just, okay, this is the environment, have all the facts right off the bat, versus the other one is like, okay, I don't have all the environment information off the bat. Only at the end am I given that extra bit of information. Oh yeah, he's a clergyman.
So that's what's going. I guess I don't understand the question / comment.
How is this different than a contextual problem? Say
I don't know what you mean by a contextual problem.
the difference between a snake and an eel.
Uh-huh.
Like, they both look perceptually similar, but the context of the picture of them, of one being in the ocean and one being on land, is different.
Mhm.
So if I distract you, what is a legless creature that has no fur, slithers around, and then I say, well, eel, and it's like, okay, well, yeah, it's going to be in the ocean or something like that.
But they've given you the same amount. I hope you agree. They've given you the same amount of information, the same basic facts in both of these two versions. That was what they were trying. So they tried to control the actual propositions that they give you and give you identical propositions, just in a different order. Yeah.
Does that order not change the way we, well, clearly it changes.
That's their whole argument. Yeah, the whole argument is that they change. What they're doing is changing the order in a way that helps you, that would shift you from one mode of processing to another. Just having facts go through your head in a very straightforward propositional way versus having facts come in that you are puzzled by.
Is that changing the information, or is that changing the way in which I see that information?
They're very much trying to make it a difference, identical information, but a difference in the way you process it.
All right.
So again, why did I try to make you guess which one of these would work? It's in the slide. It's not in the slide, but it's in this question. Because if you just tell somebody something, if you just tell them the answer, they don't retain it as well. They're not as able to use it in future contexts as if you give it to them as a thing that they have to think about for a second. Which again should make you despair for the structure of your education thus far, because they've just been telling you stuff and asking you to repeat it, rather than making you puzzled, giving you weird, ill-defined problems that you have to struggle with, because you don't want to struggle. You very reasonably want to use the minimum amount of energy on a given project, because you're a mammal and you're burning calories like crazy just to sit there. So I'll continue to do this and make your life difficult because I want you to learn stuff. Okay, let's do another. So Adams et al. Reproduced the same result. Where am I here? So they did the multiple marriage problem and some others, all of which sound like bad jokes. They gave people the following sort of problem. Can you make a tennis ball go a short distance, come to a dead stop, and then reverse itself, and then and go in the opposite direction? So it moves, it stops, it comes back. Give people a sec. Note, bouncing the ball is not permitted, nor can you hit it with anything, nor tie anything to it. Okay, now you can go.
Two choices.
Yeah,
One, probably what I'm looking for, just hit it up.
yeah,
Two, serve it to somebody.
yeah. I suppose if you have a competent tennis partner, you could just serve it to them. The one that they were looking for was throw it up in the air. Yeah. Yeah. Yeah.
Could you just like move it?
You could like, I suppose you could. Yeah. Okay. So they were, and yeah.
You could also like give it a spin.
You'd have to give it a wicked spin, but I suppose you could. I suppose you could. You could do this in pool. If you give it enough backspin. Okay, so it's the same basic thing. They gave them a whole bunch of these really unfunny, jokey sounding things, and then tried to get people to generate the answers, having given them the same basic task before. Give them a reading task, a whole bunch of sentences, some of which contain hints to this type of problem. And they gave them 2 different types of hints. So they say things like, if you throw a ball into the air, it comes back down. That was the declarative sort of like gives you, if you throw a ball in the air, okay, now I'm thinking a ball in the air, then it will come back down. So you're at no point confused when you're reading that sentence. There's no processing, there's no like puzzling or whatever. Or a ball will always return to you if you throw it up in the air. Okay, here's another one. So here's the problem. This mynah bird, said the pet shop salesman, will repeat anything it hears. A week later, a lady who brought the bird back, who bought the bird, was back in the shop to complain that she talked to the bird, yet it had not said anything. Nonetheless, the salesman told the truth. What's going on? So if they gave people the cue, a deaf parrot will not learn to mimic sounds, there was no facilitation of figuring this out. But if they told them a parrot will not learn to mimic sounds if it is deaf, then they would. The parrot was deaf. So it repeats anything that it hears, but it doesn't hear anything. Wah, wah. Okay, so, okay. Oh yeah, all right. Wow, I wrote that all out. Huh, good for me. Okay, so I hope this solves at least one of the concerns that you had with the last one, which was like, it was like beat clergyman. Ta-da! That's a really weird way of speaking anything. It was literally just, these are exact transcriptions of the quotes. So the semicolon presumably doesn't alert you that anything really deep and important is happening. So that might help sort that out. But nonetheless, you might still worry that these are different sentences. They're not the same stimulus. So really briefly before I go on, I just want to call back to something we talked about last time, which is this verbal overshadowing idea. We talked about how getting people to articulate their thinking process when they're doing insight problem solving seem to inhibit their ability to do the problem. And one thing that you might be tempted to take away from that is that language inhibits insight problem solving, that giving people linguistic cues makes them worse at problem solving. And I think the experiments that we've seen so far today show us that that can't be quite right. It's not language exactly that's inhibiting people. It's not the use of linguistic cues. It's not that giving people sentences makes them worse at problem solving. Because we've seen a bunch of examples of sentences, they're just sentences, like you didn't give people like, teach them a new skill or something like that. You give them sentences and it can facilitate problem solving. So just to nuance that a little bit, you know, the verbal overshadowing things seem to suggest that insight problem solving is just like dancing or something. Like if you have to deal with language while you're doing it, that's going to degrade your performance. But here we've seen a bunch of examples of language used in one particular way actually helping people to do insight problem. So language used as just giving people a series of facts, at least in this case, even facts that look like they should be super relevant, right? Like you're giving people the answer to these questions and then 20 minutes later asking them to solve them. So I can't imagine more relevant sentences to be giving people, but if you give it to them in a declarative form, in a fact form, it doesn't help. But if you give it to them as a puzzle to engage them in a different way, to get them to process it differently, then it does help. So Language isn't the problem. That's the sort of, just to remind you of that thing we talked about last time. You might be tempted to say like language is what interferes with insight problem solving, and if you could just get yourself in a totally non-linguistic state, you'd be a brilliant insight problem solver. That doesn't seem to be borne out by the evidence. It seems like language used in one way doesn't help, but language used in another actually can help. Yeah? Yeah.
But doesn't this vary depending on people's understandability of like fact versus puzzle version? Because like me myself, I find it easier to remember and understand something when it's given as a fact than as a puzzle.
Really?
Like, yeah, having to like fully go through the process of understanding and potentially not getting to like the goal, the answer, doesn't make it easier for me to remember. It's just like easier for me to remember if somebody told me that a deaf parrot will not learn to mimic the sound, because I can imagine very easily like a deaf parrot not being able to mimic a sound.
It's possible that you're not like the average person. So these studies tell us what the average neurotypical person is like. So that's, people vary widely in the way their minds work. These studies can only tell us what the average person is like. So, yeah.
Also, if like we're going fact versus puzzle version and saying that language isn't like a variable to kind of like memory and retaining, you know, sentences or strings, how do we treat this for like building artificial intelligence and like telling it that it should be this versus that? Because shouldn't we be like telling it like this is a dog, that is a fact, instead of trying to make it, you know, question itself of is this a dog? I don't know what a dog really is yet.
So that question sort of skips forward into the second third of the course. Artificial intelligence in its original form was entirely inferentially based. So it's exactly the kind of thing that the search inference framework thought problem solving is like. But we'll see that didn't really pan out. So building artificial intelligence as a kind of logical operators, crunching away at stored data, we call it good old-fashioned AI, and that project really didn't go that far. What we were replacing it with, or the kind of current, the sort of in the 90s, we replaced it with neural networks. Now we're experimenting with dynamical systems, of which neural networks are a specific type. And those seem like much more like skill-based processes. So the fact for a good old-fashioned AI program, there would be zero difference between the fact and the puzzle version. Those would be identical to it. But that research project really didn't pan out. It kind of hit a dead end in a variety of ways that we'll talk about in great length in the second third of the course. So maybe that'll help answer your question in more depth. I don't know currently how we would get an AI to kind of appropriate the difference between these two things. I don't know if we're there yet in AI research. Yeah. Other questions about this stuff? Okay. Okay, so a few of you are legitimately concerned about the fact that those are really different cues. So the fact version, the puzzle version, those are different. So of course, it may be not that unexpected that if you give people different hints, they respond differently. Maybe that's not anything to do with the way that they've appropriated it. Maybe it's just they're different hints. So, as promised, here's Needham and Begg. Needham and Begg being, of course, a folk duo or something like that. I don't know. They sounds like they should have a band, Needham and Begg. Anyway, no, they're psychology researchers. So they actually reproduced this result with identical hints, word for word identical hints. The thing that they varied was with just the instructions that they gave to people when they were reading it. So they were told, so you get some people in, you got a, let me see, do they have a control group? Right, so you got a control group, a memory-oriented group, and then a explanation-oriented group. So you give the same hints to people. You tell one of them, I want you to read this in order to remember it later. Try to remember it. You tell another group, I want you to read this in order to explain it later. I want you to explain it later. And then the control group, they just gave it to them. So, and then analogous problems were presented. And the test was, how likely are you to transfer from the previous problem to the current problem? Which one do you think had better transfer? Yeah.
The one where they have to explain.
The explanation group. Any thoughts on why?
They have to remember it in different ways.
Yeah, that's right. So when you're trying to remember something, what you're trying to do is reproduce it later, right? You're trying to get the facts, the details of the facts. When you're trying to explain something, you're trying to appropriate it in a different way. You're trying to understand it deeply, right? And when you try to understand something, when you remember what we said about explanation in the very first class, what does an explanation do? What does a really good explanation do for you? It allows you to use your understanding of one thing and transfer it to many other things, right? So Newton worked out his laws of motion on the planets, and he was able to transfer those laws of motion to cannonballs and things rolling downhill and all kinds of physical phenomena. So that power of transfer is what makes something a good explanation. When you explain something, it very naturally makes you more able to, like if you're appropriating it in order to explain it, you're trying to extract general principles, right? So what an explanation does is when something weird happens and you want it explained, one of the ways of explaining it is to give somebody a generality, a generalization about it. So like, you know, why are lemons sour? And you say, well, lemons are acidic, acids are sour. So, and then you can say, okay, I can take that explanation and understand why other things are sour as well, right? So anything, you can extract the generality from that. Acidic things are sour, and say, if I've got another acidic thing, I can reasonably predict that it's going to be sour too. So telling people to take something in order to be able to explain it is giving them precisely the instructions to appropriate it in a transfer appropriate manner. And on your test on Thursday, I've asked you to explain the concepts to me, which is not a coincidence. That's why I'm trying to get you to appropriate the stuff in a way that you can explain it later, because it is my possibly vain hope that this stuff might actually help you later in your life and that you might be able to apply it to a whole bunch of different areas. That's been my experience with this material. I hope it is yours too. Yeah.
Is this basically the difference between like rote memorization and struggling through your problem to kind of understand it?
So when they're given the hint, they're not trying to do problem solving yet. They're just trying to read the text. Yeah.
There's a bit of puzzle solving depending on like the amount of hints.
So
I'm saying like one, you're struggling a bit more versus just you're giving the info.
in a sense, trying to read something in order to explain it later is doing a kind of puzzle solving. That is, you're trying to extract generalities from it, which is a difficult inferential task. And doing that, trying to understand something in a way that you could produce what's general about it later, makes you better at transferring it to new. At least that's what this suggests. Yeah, teaching somebody something is one of the best ways to remember it long term. Teaching people, any teacher or student who is engaged in peer teaching that I've ever talked to says, teaching something makes it much more vivid for you, much more able to recall it and transfer it at will. Which is why study groups are a good idea. That kind of thing. Okay. Okay. Good there? Okay. Here's another one. Here's Gick and McGarry, learning from mistakes. Again, they're trying to figure out what makes somebody likely to be able to transfer understanding or something they've got from a previous problem to a future problem. And in this one, they're doing the good old mutilated chessboard problem that we saw before. So recall the mutilated chessboard problem. You've got a chessboard and you knock out two opposite corners, and can you tile the whole thing evenly without any overhang or overlap with 31 dominoes? And what they did was give people a series of problems that are easier than the mutilated chessboard. So they gave them really easy versions, relatively easy versions of it, and then tried to see when they were able to transfer that understanding, or what facilitated the transfer of understanding of the easy problems to the harder version. So the hardest version of the mutilated chessboard problem is just a completely blank grid. Just give them a completely blank grid with no cues whatsoever. You can give a slightly easier version by putting the black and white in. You can do an even easier version by making it red and black. That sort of like makes the difference, the fact that one domino covers two, more salient for people. It makes it jump out more. And that's the solution to the problem, right? The way to find the solution to the problem is to notice that you've got this parity issue. They did a bunch of weird and very much of their time versions of this, so you can't really see on the slide, but this is from their paper, and they've got these tiled man, woman, man, woman, man, woman. And the idea is living in the heteronormative world of 1988. The idea is that, or sorry, 1992. Seriously, go watch TV shows from 92. It was a time. So they would give them versions of this, and I think in this one it was, can you make 31 man-woman pairs? They gave it, the easiest one I think was framed in terms of a seating plan. Can you come up with a seating plan where, for reasons that baffle even them, you need to seat only men next to women and only women next to men? Anyway, so these are supposed to be ways of making the framing that lets you solve this problem more salient. So recall that if you try to frame this as a tiling problem where you're just seeing whether you can fit tiles, seeing whether there's a tiling solution is combinatorial explosive. You're not going to solve it that way in any kind of quick or straightforward manner. But understanding it as a parity problem where, yes, you have to cover both, in this case, a man and a woman, and therefore there's two women, therefore you can't do it. So making that salient made it easier for people. They actually had a really interesting result. The interesting result was that people did best if they failed on a previous problem. The people who had the most facilitation on solving the difficult version of the mutilated chessboard problem were people who had failed earlier. So you give them an easy version, they either succeed or fail on it. Everybody gets told the solution, whether they get told whether they got the solution or not. And then you do a distractor task, and then you give them a mutilated chessboard. And the people who did best were the people who failed the easier task. So what that means is that I should give you a bunch of tasks which you are almost but not quite able to accomplish. And then your failures will propel you to success. Maybe not. But there is a life lesson here though, right? There is a life lesson, which is that if you can pay attention, if you can stand to pay attention to your failures, they will be more instructive than your successes. You've long since passed that point in your child development. So when you were super duper young, the probability of you getting something right was pretty low. So people were like, anytime you did something right, people were like, hooray. I hope they were nice enough to tell you when you were succeeding, right? That's the most informationally valuable thing that you can do for a child who's mostly not going to succeed, is tell them when they've succeeded. But you've long since passed the point where you're succeeding more than you're failing. I promise you that's true. You made it this far. I promise you're succeeding more than you're failing. So your failures are actually the most information-rich parts of your experience now. So if you can try not to, I mean, you don't want to dwell permanently on them, but if you can think hard about them, those will facilitate doing better on problems in the future. Transfer, because it's, and there's a bunch of ways to interpret this. I think one reasonable interpretation of this result is that if it's a failure, it remains in your mind a problem, right? It's a kind of knot in your brain. You say, I didn't get this last time. I didn't get this last time. So it remains encoded as a problem to be solved, whereas if you just solve it straightforwardly, it gets transferred as, here's just some information. Here's a thing that happened to me. So you've appropriated, if you in the failure scenario, you still got it appropriated as a problem. And then when you see a similar problem, you've got it encoded in the right way to transfer. That's what I would suggest. Okay, so all of this has been trying to explore, we're still trying to explore the debate between the search inference framework people and the Gestalt people. And again, the search inference people think that insight problem solving is really fundamentally searching through a space of inference, possible inferences that you can make. It's manipulating logical propositions until you get the solution. And everything that I've said so far today kind of suggests a picture in which insight problem solving, although it's not just sort of like this super linguistic, mystical, like magical thing that happens in your head, language can help. Linguistic cues can facilitate insight problem solving. Nonetheless, it doesn't seem to be just inferential. It doesn't seem to be that giving people the correct propositions gives them the ability to solve these problems. Giving them propositions in the right form, that is, in a form that makes them, engages them as problem solvers, as gives them the opportunity to engage with this stuff in a skillful manner, right? In a procedural way. So giving people procedural cues seems to facilitate the procedural skill, is what the Gestalt people think it is, of insight problem solving. It's an ability rather than an inference that you're making. That's been the point of all this stuff. Okay. So far, so good? Good. Okay, so here's Weisberg. It's the same Weisberg as before. Remember Weisberg and Alba, who were the first people we talked about with the search inference framework? Weisberg and Alba were the ones who were trying to extend the Newell and Simon's work into insight problem solving. So by 1995, Weisberg writes this chapter in The Nature of Insight where he admits that it's a real thing, that it's a basically different type of problem solving than non-insight problem solving. So in some sense, this debate, at least one person involved in this debate has sort of admitted that he's been convinced, like a good scientist, by a bunch of evidence and reasoning and arguments. So insight is what Weisberg says is a thing. But he wants to make a really interesting point about insight, which is that it's insight problems, is that they're not, careful with this, but it's not a thing in the world. So, I mean, problems, in a sense, are not a thing in the world. The world has no problems. We have problems, right? We're the ones with the problems. The world is just sitting there being a world, yeah? A problem is not a thing in the world, in the sense that chairs and tables and atoms and stars are things in the world. Those all continue to exist regardless of whether we care about them or notice them or any of that stuff, right? So let's say a thing in the world is something that's still there when you're not paying attention to it. It's still there. Even if there was no observers in the universe, it would still exist. By thing in the world, let's say that, so that we don't get mired in too deep philosophical waters here. So insight problems, he wants to argue, are likewise, they're not a thing in the world. And you might already sort of see why that's the case. Because how do we describe insight problems? We said they're problems which people tend to misframe, right? They're problems which people tend to formulate them in a way that's not going to let them solve them. So what if you formulated it the right way? Is it no longer an insight problem? I would say that for babies, learning object permanence is probably an insight problem. They must have this magical aha moment when they figure out that you're still there when you're doing the peekaboo thing, right? When they finally put it together, like, oh, mom's not gone, she's just hiding. That must be the most incredible like rush of joy, and like suddenly the world, you can put your whole world together in new ways, new and interesting ways that you never could before. You've restructured the whole problem of tracking objects in your environment, which before the objects were only there if you could see them. Now, oh, they're still there. But I take it that we've all got the object permanence thing more or less sorted now. This is not an insight problem for you, right? When you're tracking an object that goes behind another object, you don't have a magical aha moment when it reappears. That's right? Typically. Okay? So insight problems are not a type of problem per se. Insight problems are problems that we happen to tend to misframe. And if we'd had very different histories or very different training, maybe we wouldn't misframe them. And this is a fairly reasonable point. And what it suggests is that you can't have a theory of insight problems per se. What you can have a theory of is insight problem solving. Yeah? Yeah?
Has anyone done studies on like what people in maybe different countries or who've gone to different like types of education, what kinds of problems they tend to misframe, and sort of like commonalities between those problems?
Not that I'm aware of. Not that I'm aware of. I'm only aware of one research program on cross-cultural differences in cognition, and it's not one that has stood up to a lot of it hasn't been reproduced very well. So Richard Nisbet and his collaborators have done a bunch of work trying to understand how causal attribution happens in different cultures, and their basic argument was Westerners tend to focus on the object, categorize the object and understand it as an individual separate from its environment, and Easterners tend to see the relationship between the figure-ground relationship. He wrote a bunch of papers and a bunch of books, and I'm told that it's not a research program that went super well. It kind of fell apart. But he was at least trying to do this. I think it's a very worthy task to try to see cross-cultural differences in cognition. I would not be at all surprised if there are some. But typically, research on this stuff happens, what you do is you take a bunch of undergrads from one university and test them. And there's no interest in like trying to understand where they came from in the world or any of that stuff. So it's a thing that people have at least begun trying to face up to, but it's not a research program where much progress, as far as I know, has been made. Yeah. Frontiers of psychology. These are interesting and important questions to which we do not have answers currently. Okay. So, Weisberg's fairly reasonable conclusion, I would say, is that what we need is a theory about how we process insight problems rather than insight problems themselves. So, fair enough. Here's a study that basically tries to do that. Tries to find the signatures, the neural signatures of insight problem solving. And they found some. So they put people into an fMRI machine, functional magnetic resonance imaging machine, which I believe the fMRI gives you really good spatial discrimination. So you can see what's happening on fairly small scales in the brain, but not very good temporal resolution. Anyway, so, and then try to solve various problems and report when they had an insight. So they're assuming that people have access to the phenomenology of insight, the aha moment, I asked you earlier, like, have you all had the aha moment? And I got some nods. Nobody stuck up their hand and said, no, I have no idea what you're talking about. So this experiment assumes that you've got some understanding of what it feels like to have an insight. And then asks subjects to report that moment. Tell me, when did you have the aha moment? And of course, having the aha moment isn't necessarily the moment of producing the solution. So you can't just test when they produce the solution. The aha moment can sometimes come substantially before the solution. In my PhD, I had them like 4 years before I finished writing the stupid thing. So like it can be a bit of a walk to get from the insight to the actual solution. So what they have is people report the solution, not report when they had the solution, but report when they had the insight. And then they looked at what's going on in their brain. And what happened when it's going on in their brain, they're working away, they're working away, they're working away, and the activity is mainly centered in the left hemisphere. And the aha moment seemed to be correlated with a shift, a large shift into the right hemisphere. So there seems to be a neural signature of the aha moment. Let's spend some time trying to unpack what that might mean. Yeah?
I was going to ask if you think, like, do you know how there's a difference between people who think with their left brain and their right brain?
I've heard that.
Okay. I don't know if that has anything to do with, like, activity shifting from left to right hemisphere. But could it be that, like, people who are more left brain, when they analyze the problem at hand, they're using it, and then the aha moment is when they realize, like, there's other ways to perceptually see this, and so it starts cueing in their right side of the brain, and that's what they're seeing?
That's more or less the thought. Yeah, yeah, yeah. But let's unpack this a little, because there is a humongous amount of misinformation about what left and right brains do. There have been an enormous number of myths and so on. The myth is that your left brain is a kind of logical fascist, that it loves rules and order and button-down shirts, and that's what it loves most in the world. And your right brain is an artist, a poet, a lover. And that if only you could somehow live more in your right brain, you would just be happy forever and everything would be great. And that's, you can tell from my tone of voice that I don't think that's right. So this is not a neuroscience class. We are not going to get deep into this. I'm going to offer you some really rough generalizations about the state of play on this stuff. Yep.
Did you get into any studies of like brain damage in individuals? Because we have a
Yeah,
paper that got categorization.
I'll talk a little bit about that. Yeah.
Okay.
Yeah. Just hang on 1 minute. Yeah. Okay. So here's my really rough version of this. So your left brain seems to deal with sequential, detail-oriented, local things, and your right brain seems to deal with parallel, global, holistic processing. That's more or less the state of understanding of these two things. So recall the difference. I think it's a very important thing to keep in mind between well-defined and ill-defined problems. So in a well-defined problem, you know what the operators are. You know what the goal state is. You know what your initial state is. And it's really just a matter of applying the rules. You know what the rules are. It's just a matter of applying them. And that seems to be a left brain kind of thing. So when you're doing a math problem, you really don't want to be saying, it's 87-ish. Call it 88 just because I like repeated numbers, right? Like you want to be precise. And if you're rushing, if you're doing things quickly, you tend to lose precision, right? So left brain stuff seems to be the stuff where you're doing things one thing at a time. It's better at dealing with details, getting the details just right, and it's better at like focusing in on one thing rather than the whole picture. And that's an important class of problems that you face. By the way, this seems to be like it used to be thought that this hemispheric specialization was like just humans. but it seems to go back millions and maybe hundreds of millions of years in evolution. Like hemispheric specialization, the division of labor between the hemispheres seems to be very, very old. Okay, so you're working on a math problem. You're applying rules. You're paying attention to, like, your nose is in the paper and the world has disappeared for you, right? Hopefully, if you're really focused, you're not paying attention to anything else. And then a tiger walks in the room. And you are going to shift massively from your left brain to your right brain. Because suddenly, the details don't matter too much. Suddenly, you also need to take in the whole situation all at once, and you need to act fast, right? So you're going to shift, given that change in situation, you're going to shift from left brain processing to right brain processing, right? You're going to massively shift the kind of processing that you need to do. And it looks like your brain's got a division of labor where one half deals more with one, left brain with the details, the parts, the specifics in a kind of linear way, and the right brain deals with bringing it all together into a whole and doing things in parallel and doing things fast. Does anybody remember who wrote Thinking Fast and Slow? Can't remember. Yeah. Kahneman. Thank you, Daniel Kahneman. Yeah. So Kahneman argues that we basically got two cognitive systems running all the time, one of which is slow. It's like doing logic, doing math. You want it to be slow, precise, careful. And then you got fast thinking, the thinking that you do when you need to assess a situation immediately. And it doesn't matter if the details are exactly right. You just need to get things done. Right? You need to have it and you need to have it done in a way that's context sensitive. Yeah. So system 1, system 2, they sometimes call it left and right brain. Yeah.
Is the left brain then in a sense imperative that it's kind of being this is a recipe of things I'm going through each one of the orders versus the left brain is more so why am I doing this recipe, or like what is my goal in the recipe?
So right brain does seem to be more active when you're doing emotional processing. But I'd like to, what we shouldn't think, and what it's tempting to think, is that one task, you're just going to be all in one hemisphere, and the other one's just sitting idle. And that really doesn't seem to be the way the brain works. These halves coordinate almost all the time. So like one of the common things that people say about the right hemisphere is that it involves creativity. So if you're doing a creative project, you're all in your right hemisphere. But any creative project that I've ever engaged in, so for example, writing, if you don't have the details well formulated, your writing is going to be terrible. And if you're not able to assemble those details into a coherent organic unity, your writing is going to be terrible. So like most of the, maybe there are creative activities that are more freeform than the kind of boring stuff that I do. But whenever I'm engaged in a creative project, I find that I have to have both of those interacting all the time. And the two are connected by the corpus callosum, which is a kind of bridge that keeps them together. So like, yeah.
So is then saliency, from a naive perspective, located more in the right brain of how much we care about things and how emotions influence us? Or can we use inferences to build up our saliency of something as well? Like
So I think you have to be tracking salience when you're doing inferences as well. So you have to be understanding what's important like what's relevant to solving this equation is a left brain kind of thing, right? So we're gonna see the argument, we're gonna develop the argument in the last third of the course that salience is judged at every level of processing in the brain. That's gonna be the argument, that basically you don't have any processing without the assessment of salience, and that it's happening everywhere in the brain all the time. That's a long argument. I can't really do it now, but
Could
yeah.
it be argued? Because I know that there's like in most people like strong lateralization of language
Yeah.
in the left brain.
Yeah.
Could it be that your energy is like focused when you're trying to understand a problem? You're like really language is like very important and trying to solve a problem likewise. And then when you have that aha moment, it's almost like an emotional response that your body's having, and then you're trying to remember that information. Is that
Maybe. maybe. Certainly there's an emotional dimension to the aha moment. That's certainly right. But I think we should resist the temptation to have this be the logical and emotional sides of this. Is one of the most common sort of like stories about left and brain, is that there's the thinking part and the feeling part. And that doesn't seem to be quite right. So let me show you something to help illustrate this. And I think it's probably easier, probably not easier, but more accurate to think of it as the local and global processing, serial and parallel processing, something like that. So here's a construct that's been used in a variety of contexts to study this stuff. They're called Navon letters. So you get it, right? Since you all have both functioning left and right hemispheres, you can tell that that's a big A made up of little e's, right? Good. Okay. Now, Navon introduced these in 1977, and his idea was to try to study global and local processing. So when you're understanding this as a large A, what you've done is taking a whole bunch of local facts and put them together into a whole, right? And that seems to be mediated by the right brain. Whereas if you see a bunch of E's, what is that? That's an E. You're in a more local level of processing, okay? And if you take somebody, so it was earlier asked if we were going to talk about sort of brain injuries, brain insults. So the global shape, the A, seems to be processed mainly by the right hemisphere, and the local shapes seem to be processed mainly by the left hemisphere. The evidence for that is partly drawn from things like brain scans, but also partly drawn from people who've had some sort of injury or problem with one or the other of their hemispheres. So if you have somebody with a left brain injury, so the local processing, they'll draw you an A. So they'll get the overall shape of the thing. They won't draw an A made of little e's, they'll draw an A. Whereas if you have somebody with a right brain injury, they'll draw you a bunch of e's, but they won't be in the shape of an A. They'll just kind of be there. So what they've got are the details, the local details, but not how all of those details fit together into a whole. Yeah? So, and interesting things come out when you can get people to attend to either the global or the local level, or both at once. So you can give people the following instructions. Just tell me what the little letters are, or just tell me what the big letters are, or tell me both. And in all three of those tasks, if the little letters are the same as the big letters, people do it faster. Which suggests to me that we really shouldn't think of the two hemispheres of the brain as operating independently of each other most of the time. What they're doing is cooperating. And if you get the same, if your global picture and your local picture are the same picture, that feels really good and it's easy to process, right? When they agree. Yeah?
Does that mean if there was a big E that's made of little E's?
Yeah, exactly. So if this was a big E made up of a bunch of little e's, people like that. It's easier for them to process. They'll process it faster. So you just got both hemispheres getting the same answer. And for people, that's a really satisfying thing. And it should be intuitive that that's what you'll like best, is that you've got two brains. This is why we used to call them brains, by the way. Brains because there's two of them in your head. 3 if you're counting the cerebellum. If your brains are agreeing, you've got a division of labor, you've got two different ways of approaching the world, two different ways of seeing the world, and they come up with the same answer, you should be like, yeah, great. And that seems to be what people do. We really like this. Okay, so what does this have to do with anything? Why am I telling you about the brain hemispheres? What's going on? Okay, so here's another creepy thing. Here's an experiment with what's called transcranial direct current stimulation. It's literally hooking up a 9-volt battery to your head. So you can do a bunch of different things with this. It's used to treat a variety of different, this is not a prescribed treatment yet. It's all still in clinical trials, but the clinical trials seem to be at least modestly promising. You can use it to treat all kinds of conditions. You can increase focus. You can make people better snipers with this kind of thing, which you never guess who's interested in that. So you can alter you all know how brains work, right? There's a bunch of synapses and they fire. Yeah, that's an electrical potential moving around the brain. This is not news to anybody. So what this does is mildly alter the electrical potential of the neurons. Neurons operate at something like 0.1 of a milliamp or something like that. So it's like 10 times weaker than the actual amount of electrical potential you need to get it to fire, but it can change the potentials. And if they call them for some reason the position of the electrodes and how much power and how long you use them is called a montage. I don't know why. Given the right montage, you can get spontaneous solutions for the 9-dot problem to go from approximately 0 to something like 40%. So massive facilitation of this insight problem. Yeah. Oh yes. Yes, for one, you got a 9-volt battery strapped to your head.
Besides electrocution, so like,
Besides electric,
other kinds of problem solving ability to
yeah. Well, so basically, in this particular montage, in the one that facilitates insight, what you're doing is shifting activity from the left to the right. You're getting people to gestalt more. What the downside of this is that it seems to reduce how automatic your responses are. So remember what we said about insight problem solving. You've got a kind of spontaneous automatic approach to the situation. And it's misled you. That's what's characteristic of being an insight problem situation, that you're misled by the automatic way that you frame something, and then you get frustrated enough that you take a step back and try to reframe it. You try to do problem solving on problem solving. So this montage that they used made that process less automatic. But you don't want to live on manual. You want almost everything that you do to be automatic. Like it's an annoying thing to do to people to say, you are now breathing manually. Right? You can now feel your tongue. It's a kind of mean thing to do to people, sorry. Because those are automatic, those are totally automatic processes. You kind of want those to almost always be going on automatic. When you go home, you don't want to open the door and say, okay, now I have to resolve this room into objects, okay? There's the couch, there's the TV. You don't want to be doing that manually. You want practically everything that you're doing to happen transparently, automatically. You want your brain to take care of it for you. So this montage helped insight problem solving. So it de-automatized part of the way you formulate the world. But you don't want to live like that. That's not a good way to live permanently. Yeah? I would suggest. Okay, but it does seem to be a bit of evidence for this insight as left brain, right brain stuff. In the sense that, and so recall Weisberg's suggestion at the beginning of this lecture that there's two different kinds of search going on. And that when you get stuck in one kind, you shift. That might be right in the sense that what we've got are two parallel cognitive processors, two different ways of approaching and appropriating the world, and that your standard problem approach is the left brain one. You're like, okay, 9 dots. I'm going to try to find a way of moving these lines around to cover all 9 dots. So you're doing left brain processing. And then when you've sort of exhausted the possibilities for your left brain approach, you do a shift from one to the other. So you re-gestalt the situation. You have to do right brain processing, because right brain is what puts things together into a whole for you. And that was the problem, the way that you put the parts together into a whole. You put them together wrong. That's why you're in an insight problem. You put them together wrong. So another bit of kind of neurological evidence for the possibility that there's a kind of two process approach to problem solving. Wasn't exactly the two processes that Weisberg and Alba were presenting, but two processes nonetheless. Okay. So here's another one. Just to kind of go back to Weisberg's concern. So this shift, so the last little while we've done a shift from insight problem solving to the process of insight problem solving, like what kind of processes are we using? And that might make you worry that all of the research that we've looked at throughout this stuff we're talking about insight might have been just kind of misframed. Because did we identify the insight problems correctly? Did we have how do you know that a problem is an insight problem or isn't an insight problem? That's a serious question that you might ask yourself post Weisberg's critique. You say, well, there's not just insight problems in the world. You say, yeah, but we have a list of the insight problems and the non-insight problems. How did you generate that list? And did you categorize them correctly? You might worry. You might legitimately worry. And so here's an experiment where they're doing the same kind of brain scan thing. They're also trying to, so they give them a bunch of problems which have traditionally been either treated as insight or non-insight problems, and do the brain scan thing on them. So watch what happens in their brain while they're trying to solve these problems. And lucky us, turns out we were pretty good at identifying insight problems. So those things that have been traditionally classified as insight problems show this pattern of left brain shift to right brain when the aha moment, shift back to left brain. And non-insight problems, you typically just stick in the left brain as the major bit of activity. So this is like experimental redemption for a problem that you didn't realize that we had. But this is a good bit of experimental evidence that we've at least, so there's no such thing as an insight problem in the world. A problem is neither insight nor non-insight, just all by itself. But it does seem to be the case that we overwhelmingly correctly identified the type of problem that people need insight problem solving processing to solve, right? So it's, we intuitively knew which ones were going to require people to do insight problem solving and which ones didn't. And we got it, it seems like the literature basically got it right. We basically identified the right ones. Okay. So, where are we at? I'm really going through, like last year these took me 3 hours to get through, and now they're taking me 2. I think I'm doing fewer digressions, and maybe we're talking a little less, so I hope that you will come hang out with us after class so that we can digress and discuss. Anyway, so this lecture has been making the argument that solving insight tasks is a matter of perceptual restructuring. We might say attentional restructuring, right? It's a matter of using your attention differently than you were using it before. I've been making the case to you that what we need to think about here is the way that we, and more specifically, the way that we've construed the world in terms of its parts and its wholes, right? How do you identify the parts? How do you put those parts together into a unified whole? So when you have an insight problem, you've been given a bunch of parts and you've gestalted them together into a whole, and then your job is going to be to break those parts back apart into their bits and re-gestalt them, reconstruct them into a new organic unity. Yeah?
How does this work for children? Like,
That's a very broad question.
sorry, when it comes to attention,
I'm not aware of any brain scans done on children. They tend to get very scared in the fMRI machine.
But their attention is like, oh, there's a bird. Oh, look, this rock looks like a person. I don't know. But their attention is different than our own attention. Like they catch on to things that we don't. Like there's a daffodil in the corner, and they're much more prone to being like, oh, the daffodil, and they want to instantly go ahead and touch it.
Yeah.
So they want more experiences than we do. My question is like, is perceptual restructuring something that we learn over time, and not only that, but like solving insight tasks? Can we be better or more creative at solving insight tasks at a younger age versus older, even though we learn more?
It's a really interesting question. So there seem to be developmental stages where kids treat problems differently. So I read a study recently about giving children tasks where they need to use an object as a tool, but it's not typically classified as a tool. So you give them a toy that's sort of like a rake or something like that, but there's not a rake. And if they're below 5 to 7, so below 5 to 7, and they nonetheless they're told, here's a toy, not a tool. Here's a toy. Everybody's like, yeah, it's a toy. Good, fine. When you then give children under 5 to 7 a task where they have to reframe the situation, not as a toy, but a tool, like a reaching tool or something like that. So they have to think, oh, this fun giraffe toy could also be used to pull the ball towards me, right? That's the kind of insight, right? So below 5 to 7, somewhere in that range, the kids had no problem reconceptualizing the giraffe as a pulling tool. I'm making that example up, but like, so they didn't have the fixation. Whereas over 5 to 7, if you told them, here's a toy, it was a struggle for them to then go, oh, this can also be a tool. They were actually worse at over a certain age threshold. They were actually worse at doing the reconceptualization because they had it categorized as a toy, not a tool. So in some important sense, as we get older, we get worse at insight because we've got all these expectations and concepts through which we experience the world. We've got a whole bunch of sets of like, I know what that is, that's a chair, that's a desk. And the more you learn about the world, the better you have it structured for yourself, the more that stuff is just automatic. The more that stuff is just assumed, transparent, and transparency is in some sense the enemy of insight. Because you just know, I just know what the world is for. I just know what everything is supposed to be. And when you're having an insight, you break apart that knowing. You break apart that transparency. You don't look, so the really nice metaphor, most of the time I look through my glasses to see the world. Sometimes I take off my glasses and look at them in order to, say, clean them. So if my glasses are smudged, I have to stop looking through them and start looking at them. But the more used to I am looking through them, that is, the more elaborate conceptual structures you built up, the more certain you are about what your world is like and what its parts are for, the harder it is to break out of a certain way of understanding them. And really little kids below a certain threshold don't have nearly the same kind of like, they're not as smart and therefore they're smarter in some weird paradoxical way. That is, they don't have a rigid kind of conceptual structure that they're laying over the world, and therefore they seem to be more cognitively flexible than kids just a couple of years older than them. So that's my best shot at an answer to that.
So with respect to like be skeptical moments, to always keep an open mind with it, instead of making up my mind over getting mine and everything.
Yeah.
That's a
Well, I mean, yeah. So let me be very clear. I am not suggesting that you shouldn't go through the normal developmental stages of becoming an adult. Daniel Dennett says you should have an open mind, but not so open that your brains fall out. And recall what I said about how you don't want your world to be automatic. So we've got this TDCS montage where you can you can decrease the automaticity with which they encounter the world, and therefore increase insight. But that makes it so that you have to do everything manually. And that's a nightmare. To take into its extreme, that's a really bad way to live, because you want to be using what your brain really wants, and what you want it to be doing is to deal with your world as efficiently as possible, right? So it's always trading off different constraints to find the most efficient solution possible. This is the bioeconomic constraints on cognition. You got very limited resource. They all, and everything that you do, every little tiny move your brain makes burns glucose. So you want to get through your day as efficiently as possible. And for almost everything, that means making it transparent and automatic. You don't want it to present you all of the options available to you. That would be terrible. So, yeah. Okay, so we've gotten to the point where we're thinking about, we want to understand cognition, so we tried to understand it in terms of problem solving. We wanted to understand problem solving. We found that the most human parts of problem solving, the most interesting parts, were insight. We wanted to understand insight, so that we dug down and we found attention seems to be at the heart of insight. The ability to flexibly and dynamically shape your attention in ways that both allow you to be efficient and nonetheless not get stuck in kind of cognitive ruts. So that's where we're going to go next time. We're going to talk about attention and construal, the way in which you can flexibly and dynamically change the way that you're perceiving the world in order to try to solve your problems and not get bogged down in the quagmire of having to pay attention to all of the information available. Right? Okay, let's call it a day.